Okay, so I just wanted to say a couple words about absorption and emission spectrum, since they're brought up in your homework, but they're not sort of really formally introduced until later. And I briefly talked about the emission spectrum, with the Bohr model of the atom, and how when the electrons drop a level, when they gain energy from incoming radiation, and then that boosts their level by absorbing that energy, and then when they release it as a photon of light. So now I want to just sort of show you the difference between the two, of absorption and emission spectrum, and how they lead to the discreteness of the electron energy levels. So here we have a nice little display, and here is just the continuous spectrum. That's just sort of what you'd see if you had a prism and you had white light like the sun, and or in the light bulb as depicted here, and you'd see this nice continuous spectrum, Roy G. Biv, just all the colors. But then there's another type, and that's the emission spectrum. And so this is, if you remember from the simulation over to the side, this is what led to that concept of these energy levels. So this is energy going up this way, and this is the ground state, n equal 1. And you can get this from previous diagrams too. And so n equal 2, 3, and 4 respectively. And so when an electron is up here, and then it falls to here, it emits a photon of light. And so these little photons, if you think about it, give rise to these lines here on these emission spectrum. So that's pretty easy to understand. So atom, its electrons absorb incoming radiation. They gain energy. The energy causes them to go up a level, and when they fall back down, they give off these emission lines. So everything else is black, but except where the lines were emitted, where the colors were emitted. And we'll be able to see this later in class. So, but think about something else. So what if you had white light? So remember, this came from a hot gas, and so like you heat up like I did in the cathode ray tube. So, but what if you shined white light, which gives you this up here, it gives you the continuum spectrum, but you shined it and you had it go through a cold gas. See right here, you can see the cold gas, and then it went through the prism, and then that separated it out. Do you remember what it's called when light goes through a prism? It's called dispersion. So the separation of light, and so now it gives you the color, the continuous spectrum minus the incoming radiation that was absorbed by this gas, and hence the name absorption line spectrum. So, but notice that if these were the same gas, that you would get that the lines match up. The emission line spectrum matches up with the absorption line spectrum. That's because remember the discreteness of the atom is that it's absorbing at that energy or it's emitting at that energy, but it can't be in between. So absorption at that energy level or emitting. And just a quick reminder, we'll get it later, but that energy can actually be figured out by E equals hf, where h is Planck's constant and f is the frequency of the wavelength of light. And we can talk a little bit more about that when we get to the photoelectric effect. All right, so that's the difference between absorption and emission spectrum, and then we'll stop on that.